relation between the horizontal range denoted by r and time of flight for the projectile which has been thrown from ground and it lands again on the ground. In this case, just consider one projectile which has been thrown at some angle with the ground. Trajectory of its path may be drawn as this blue color line, in which what we have to find is relation between r and t. What we have been given is velocity of projection u at an angle theta with the horizontal. What we know about this projectile is its horizontal range, which is basically the distance from this point O to this point where this projectile lands. So horizontal range R, which is equal to OL, can be given by u square sine 2 theta divided by acceleration due to gravity g. Time of flight in traveling from O to L, it can be given as t, which have the value 2u sine theta divided by g. Here if we find r upon t square, then it will become, so this becomes g upon 2t sine theta. By using these two values into this function, it can be modified as r tan theta equal to half gt square. So the final result for the relation between r and t, we can write r tan theta equal to half gt square, where tan theta is the tangent of the angle of projection theta. Say two projectiles are thrown at angle theta and 90 minus theta. In other words, we can say one is thrown at angle theta with the horizontal while other at theta angle down the vertical. In this case, we can easily write time of flights for two different angles of projection which are complementary angles. So time of flight for angle theta is t equal to 2u sine theta divided by g. While for angle of projection 90 minus theta, the time of flight t dash, it can be written as 2u cos theta divided by g. Now, if we do t multiplied by t dash, then it comes 4u square sine theta cos theta divided by g square, or t dash is equal to 2 upon g times u square sine 2 theta divided by g. Now as horizontal range r is u square sine 2 theta divided by g, so that result t dash equal to 2 upon g multiplied by the horizontal range r, or we can see here that r can be written as half g t dash, which is the desired result between r and time of flight for two complementary angles of projection. If you see, if we go through these operations, then we can say that here in time of flight u cos theta comes from sine 90 minus theta. That's why for that complementary angle of projection, time of flight becomes 2u cos theta by g. Here what we have done, we have extract 2 to be out of bracket, and at the bottom it is g. So u square sine 2 theta by g, it becomes range of the projectile. Here in this result, we can easily say that the time t is time of flight for angle of projection theta, while this time t dash, it is the time of flight for angle of projection 90 minus theta.